All right, so how many of you have seen a Venn diagram before?
Venn diagram?
Okay, good. Okay, so 15.10 is called mutually exclusive and independent events. And so if you have a set of numbers, like the set A is 1, 2, 3, 4, and set B is 3, 4, 5, 6. If you were to put that in a Venn diagram, you would look for what?
The similarities of the picture.
Right, what do they have in common?
The 3 and 4.
Right, so you see the 3 and the 4 and the 3 and the 4. Okay, so if we draw two circles overlapping like that, we'll call this one A and this one B. 3 and 4 is in both. Okay, and then A also has 1 and 2, and B also has 5 and 6. And so we're going to talk about their notation, how they're going to classify this. So if you see A with this upside down U, does anybody know what that one is called? The upside down U. It's called the intersection. The intersection of A and B. And so you would say the intersection of A and B is what? We already pointed it out. It's just 3 and 4, right? Versus if you have A with the U going up. Does anybody know what that one's called?
A U.
Union.
Oh, A.
Yeah, starts with U. So union is going to be everything that's in both of them, right? And even though 3 and 4 is listed in both of them, you don't have to list them twice. If you did, it would just be extra work for you. It's not like you would get it wrong, but you would just say their union is 1, 2, 3, 4, 5, 6. Okay. So example 1, we're going to look at one slightly trickier, and then we're going to put it in a box. I don't. Okay. So this one got 3 circles overlapping here. Okay, and then a circle over here by itself. So this one's D, this one's easy, this has 5 and 7 in it. This one is A, it has 1 and 6, and then it has 8, 10, and 4. This one is... Oh, well, let's do B. B's over here. B has 3 and 9, and then 10 and 0. And then this one is C. It has 2 and 11, 8 and 10, and then 0. Okay, good. All right. More numbers, a little more complicated, and we're going to get a little more tricky. Okay, so part A. We want the intersection of A and C. So let me make these a different color. Here's A, here's C. So here's A right here. A includes everything, even that's overlapping in here. And here's C, includes everything that's even overlapping in here. So you should be able to see that the intersection should be the set of 8 and 10. And they do those fancy, what they call braces. All right. What is the union? What is the union of A and C? So in part A, we did their intersection. Now we're going to do their union. So their union is going to be everything that's in A. So not anything that's only in B, right? So it's going to be all of this in here. And I'm just going to go in order from least to greatest. So I see 0, I see 1, I see 2, 4, 6, 8, 10, and 11. So 0, oh, there was a 1, right? 1, 2, 4, 6,
Where's the 0?
8, 10. Zero's right there.
Well, that would be not A and C.
But it's still part of C. We want their union, not their intersection.
Oh, I get it.
Any questions on part B? Everybody's with me? Okay. Part C. Let's look for the intersection of B and C. Anybody see it? What is it?
Oh. 0.
0 and 10. Part D, the union of B and C. So it's going to be all the numbers except for these two up here, right? So what do we got? 0, 2, 3, 4, 9, 8, 9, 10, 11. Okay. 0, 2, 3, 4, 8, 9, 10, 11. All right. Any questions on part D? All right. E. We're looking for the intersection of B and D.
There is none.
There is none. Trick question, right? Okay, so we call it this guy,
False set.
empty set,
Oh,
or
set,
I have heard it called the false set before, though. Where, though?
yeah. Oh, I don't know.
Yeah.
I thought it was.
All right, so part F. Here's where we're going to get a little bit tricky. So we're going to say the union of A and B, whatever their union is, intersected with C. What? So if you cover up these two for a second, you're going to see, okay, all of this is the union of A and B, right? But we only want from all of that what intersects with C. So C is just this part. So the 0, the 8, and the 10. Now those parentheses could move around. Okay, so obviously like order of operations, do what's in parentheses first. Okay, not always just left from right. Okay, any questions on those guys? Okay, awesome. All right, I got one more example for you. All right, we've got a choice of 5 novels and 5 biographies. And we want three of those books are going to be selected to be displayed at the library. Okay? What is the probability that at least 2 are novels?
Is that 5 novels? Or?
5 biographies.
Is my writing that bad? Oh, no, you just couldn't see it. Sorry. I'm like, okay, so we're going to use combinations just like we did yesterday, and we're going to take the probability that at least 2 are novels and divide that by all the combinations. Okay, so let's do the numerator first. Let's do at least 2 are novels. Okay, so how many novels do we have? 5. So if we're going to pick out of 5, we want 2, and then we're going to multiply it by,
I thought you were dividing.
we will divide in the end, yes. Choosing, because, what is the probability? Because we need 3 displayed, so if 2 of them are novels, the third book has to be the biography, right? So we would, out of the 5, choose 1. Okay, that's going to be the 3 books that are going to be on display. Okay, so this is the novels. This is the biographies. I'll just put bios. Okay. You can either punch that in your calculator or put it in the formula, right? So if you put it in the formula, it's going to be 5 factorial over 2 factorial, 3 factorial, times 5 factorial over 1 factorial, 4 factorial. I got 50. Okay. All the combinations, let's do that now. All combos. So there's how many books total? 10 books total. And we're choosing 3, right? 3 to be on display. So if you put that in the formula, you're going to have 10 factorial over 3 factorial, 7 factorial. Punch it in the calculator, you should get 120. Now you write it as a ratio. Okay? So you're going to take that 50 and the 120, so 50 over 120. Obviously, you can reduce that, right? Divide both by 10. So you have 5 over 12. 5 twelfths. I don't think you can't reduce that anymore. Okay?